Hey guys, today we're going to be going over my top 4 favorite, most interesting Linux commands. So I picked out the top 4 most interesting commands that I thought people would like to see me go over. Now these are not the most common commands, and I would not expect everyone to be familiar with these. You've probably seen at least 1 or 2 of these though. So I want to start out with tree to start, the tree command. Now you can get the same results with ls or find, but tree just displays things in a really nice, convenient way. So you could just type tree by itself. Now this may or may not be installed on your system. It was not installed on this Ubuntu system by default. So you can just do sudo apt install tree to get it installed if you don't have it. Already got it installed right now. So if you just run it like this, it's going to run the tree command on the current directory that I'm in, but I can also specify a directory. So I'm going to do it on this copied video directory because this is a good example. Now I'm going to run this, and all right, so looks like I misspelled that, but here we go. So here we see a directory structure, and this is good for just getting a feel for the directory structure. Now you see this has a bunch of subdirectories and then subdirectories inside those subdirectories. Just some temporary directories I threw my screen captures in before I copy them off to my NAS. But yeah, this is just how I've been kind of organizing my video. You may recognize some of these names if you've been looking at some of the videos I've already published. Yeah, these are all, like I did a video on awk pretty recently. I recorded an ethtool video installing ADB and fastboot on Ubuntu. So this is a temporary videos directory of things I did screen recordings for. And yeah, a lot of these are already up on YouTube now. So anyways, that's the tree command. That's pretty helpful. Now the alternative would be to use the find command. So you could do the same thing with find videos. Now this is going to give you, notice how the output of this is just not as nice. Now it'll still give you the structure, but instead of saying like videos, instead of just showing the files underneath videos ASTF, it's showing you like the full path for each file. So it's a little harder to look at, and it's just not as clean and nice. It doesn't have the lines that show you the structure, and it doesn't have it doesn't have like highlighting in different colors. So yeah, running the tree command is a whole lot nicer. So it's a really handy thing to have installed. It's going to kind of be less useful if you have a really gigantic folder. Like you could run this on, say, Etsy, and there's just a ton of stuff in here, right? But it does give you a good feel for like the structure, right, and how things are laid out. So that's kind of that's still kind of neat. But yeah, anyway, so moving along, the next command I wanted to show you is the netcat command. Now, I believe to install this, off the top of my head, I think I had to do, and I think this actually came with my system by default. It won't always be installed on every system you use. But I just looked through my history. It was already installed when I tested this out, but I went through my history. I don't see any commands to install it, but if it's not on your system and you're running Ubuntu, it's probably like an apt install netcat. Any case, yeah, it doesn't look like I had to install it on this system. If I did, it might have been months ago and I forgot about it. But any case, so netcat allows you to open it allows you to open a socket to a server listening on a TCP or a UDP port. So, for example, the first one I'm going to show you is trying to connect to. I'm going to paste this in here. Now, this is going to try to connect to my NAS. And so this is on my local network on port 80. And now port 80 is closed on my NAS. So if the port is closed, it just returns immediately and does nothing. Now port 22 is open, but it's serving SSH. So if we want to test that this port is open and just to verify connectivity, this is a great tool for verifying connectivity to a port. So you can verify end-to-end connectivity between two systems. So you could always ping a host or do like a trace route, and that's going to get you. It's going to make sure you can reach a host, but it's not going to tell you if like that port is filtered. Maybe a firewall is blocking a port, or maybe a port's not listening, or whatever the case is. You want to test that. This is a great way to troubleshoot it. So port 22, we can connect on that, and it gives us a banner saying SSH 2.0 open SSH, blah blah blah. So that's giving us a hint as to what's running on that port. It's the open SSH daemon. Now hit enter, protocol mismatch, obviously because I'm using netcat and I'm not sending valid data for the SSH protocol, so it's going to disconnect me pretty quick. Now that is a good way to verify that SSH is running and that we can actually connect on that port. We can't really authenticate using the netcat tool though. So another thing, I want to show you a successful connection on port 80. So we're going to connect to Google on port 80, and they are listening. So I can connect here. Now if I run enter, that's just giving me white space, so it doesn't do anything. If I type in some random text here, this is going to be invalid HTTP. It's expecting the HTTP protocol, which if I type invalid characters like that, it's not, so it's going to give me an error. So notice here it says title error. It actually returns an HTML document, so we actually sent a request to, or it interprets this as a request to the web server, and it interprets it as a bad request, so it's returning us an HTTP 400 bad request, and in the title of the page, bad request, your client issued a malformed illegal request. So anyways, it's returning an actual HTML document back that could theoretically be displayed in a browser. If your browser sent this by mistake, it would return a page that looks like this. So in any case, that's a good example. You can verify connectivity to you could actually type, using netcat, you could actually type HTTP commands and actually pull down a website and get it to do an HTTP 200 return. So you could actually successfully query it and pull down web pages. But I don't remember exactly how to do that right off the top of my head, and I'm not going to demonstrate that in this video, but it's something that can be done. Now, if you wanted to quickly scan for open ports on a host, I'm going to show you how I scan my NAS. So if you wanted to just check which ports are open, you could paste in netcat-z, and I haven't checked, but Z is supposed to just let it port scan, and V is for verbose, so it's going to give you information about whether a port is open or closed or not. And I believe the Z, I'm not going to check it in the man page right now, but I believe it just checks that the port's open or not, rather than trying to connect on it. So it's not going to connect on each one, and here you just specify a range of ports, or a range, you specify the IP and the range of ports that you want to check. So I'm going to check ports 1 through 1000 on this IP address, and it gives you a ton of data. And if you scroll through this, most of them are refused, but if you scroll through, you're going to see a few where it says it actually was able to connect. So if you scroll all the way, if you scroll all the way to the top here, you'll see, for example, port 22 SSH is open, so we can connect on that port. Now, if you want to, you can combine this with grep-i, and this was just working for me. So I was able to grep this out before. It is not working now. I think I'm going to have to, maybe because this is going to std error instead of std std out, but yeah, it doesn't look like this is doesn't look like piping to grep is working with this. So maybe something to come back and look at later. But in any case, I'm going to move right along here because I'm getting a little bit sidetracked. So let's see, we can also connect on a UDP port. So by default, it connects to a TCP port. We can also connect to UDP port. So 53 is something that's often listening. Now 53 was not listening on this host, but we could connect on this IP address, and we should be able to connect to 53. We should be able to notice, so this is DNS. Now I'm not actually getting anything back, but I don't think we can actually query it, but it doesn't die immediately, so I am connected on port 53. I'm just not doing valid DNS queries. So in any case, if you were to connect on a host that's not running that, like 87, it's going to return pretty quickly. So if you were to connect on TCP port 53, it's like I'm also listening here. So you can connect on either of those. So you have TCP and UDP, the option to connect with either of those. Now, another thing you can do is to run a server. So I'm going to open up another terminal here real quick, and I'm going to run a server. So I'm going to go ahead and let's see, Control Shift and just zoom in a little bit just so you can see this. Now this is kind of like only part of this window is within the area that I'm recording, but you can actually listen on a port. So we're going to try listening on port 1234. Now 1234. All right, so this is netcat is going to listen on this port. Now I'm going to connect to that. So I'm going to jump. I probably should have just opened up another tab in the same terminal, but in any case, I'm going to now jump over here, and we're going to paste this command in here. So we're going to echo the text test. We're going to echo this string. We're going to pipe it into the netcat command, which is going to connect to my local host on port 1234. So we run this command, and that basically connects to that port and sends. So running netcat will connect to this port, and it will echo this string test into that. So it's basically sending that over the connection that it opens. So if we open this other terminal here, we see it received the string test. Now that it's done that, if we could echo more stuff, we could send more text. But for now, that's basically it. As soon as all we can do from here is just Control C. And it's going, if we can Control C on the client, it's going to close the server. The same deal, if we close the server, it's going to disconnect the client. Let's disconnect from the server. Control C, the server dies, and the client connection dies too. So this is the client, this is the server. Now, you could make more elaborate things with this, but really it's just meant to be like a troubleshooting tool. You could make all sorts of elaborate things with this, but really if you're going to do anything much more elaborate than that, you should just use sockets programming in a language like Python or something like that. But in any case, if you wanted to create a real actual server, but that is something you can do with netcat. So yeah, so that's netcat. That's basically everything I wanted to show you with netcat today. Kind of a little disappointed that I wasn't able to grep the output of our port scan. That would have been nice. I did test that before the video and it was working. I don't want to troubleshoot it on the video because I don't want to get sidetracked too much. So any case, moving on to the next command. The next command is a little bit more common. So command number 3 is lsblk. Now let's run this just to show you the command without any options. lsblk. This is a really useful and important command. And you can see here we have this is going to show you all the disks on the system. Now it's a little bit, the output's a little bit messy. It shows all these loopback devices. These are basically for snaps. This is one of the things that annoys people about snaps on Ubuntu is that it creates all of these loopback entries that pollute your output here. So it's a lot of people don't like that, but it is legitimately creating these devices, so they should be displayed here. Some people don't like the fact that they exist in the first place. But anyways, physical disks are going to be like SDA and SDB. So I have 4 physical disks in here. Now, yeah, I have SDA, SDB, and SDD. And actually, sorry, this is actually 5 physical disks. So we have 4 that are showing up as SATA disks, and another one that's an NVMe disk. Now you can see this would be this refers to the disk itself, and these are the partitions on the disk. So you'd have like NVMe 0 and 1, and then you'd have that same name right here, and a P1 for partition 1, P2 for partition 2, P3. So this is the disk that's running my Ubuntu system, and I have another one. So let's see, there are 4. So this SDD doesn't have any partitions on it. STC has 3 partitions. SDB has 10 partitions. SDA has 3. So one of these, so this one I haven't partitioned yet, but one of these is actually an M2. Let's see which one. It's got to be this guy right here. So this is a terabyte drive. So this is the one that I reserved. I'm going to repartition this, but this is one that I had reserved for Gen 2. I'm going to do my Gen 2 install on here. I installed Arch on one of these. I believe it was probably STA right here. And I forget, I think I was going to try installing Windows on one of these, but I didn't. And I think this one was going to be for LFS, so I haven't partitioned it yet. So yeah, anyways, this is a multi-boot system, and yeah, I have Arch and Ubuntu installed on here for now. So anyways, moving along, if you want to see some, it's a really useful tool if you want to look at what's on your system and you want to know like what if you want to figure out where you're installing each thing, or basically anything you want to do with disks. It's really useful. So anyways, you can do a -F and run that, and it's going to give you file system info. So it's going to tell you like the file system that's installed here. Yeah, so SDB. Yeah, so that's where I was trying to install Windows 11 and failing to install Windows 11. So I think that one was not my Gen 2 system, or yeah, I think this one is where I was going to install Gen 2, but it had FAT file system. It hasn't been installed yet, and it has these FAT32 formatted file systems. I'm not sure why. Any case, moving on. So this is where I believe STC is where I was trying to install Windows 11. Anyways, SDD is going to be LFS, and SDA is going to be, SDA is my Arch install, and NVMe1 is, this NVMe drive is my Ubuntu install that I'm running right now. So let's see here. We can, let's just, we can do, we can grep-v loop to grep out our loopback devices. This way we can only see physical disks, and we're gonna avoid all of those. We're gonna avoid seeing all of those, like these guys right here, all of these loopback devices that are used for snaps. This kind of like really pollutes the output. So if you only want to see the physical disks on your system, just grep-v loop. A lot of people don't feel like typing that every time and don't feel like they should have to, but in any case, if you just want to see the physical devices on your system, there you go. Now, the last command I wanted to show you is htop. Now, you may have heard, a lot of people have heard of this command. If you haven't heard of this command, it's a real useful command, another one of my favorite commands. Now, I'm sure everyone's familiar with the top command that will show you all the running processes on your system in real time. But the command I'm going to go over today is the htop command that shows you even more information. And by default, it's going to show you not just the processes on your system, but the threads on your system. So it's going to show you each thread for each process by default. So let's see here. You can run this command, and you can see it at the top here. It shows you each of your cores on your system. So you can see this is an 8-core system. It shows you memory usage. Now it's going to show this first section right here. You can see these are different color. Now this first part here is actual memory usage, and then this part here I believe is like caching and stuff like that. But I guess total it's 8 gigs out of 31. And let's see here, it's using swap space. I'm not sure why it's using swap space, but it shouldn't be. Any case, not something to look into now. Another useful thing, it's going to give you your uptime and your load average. So load average is pretty low, especially considering the number of cores that I have. I mean, it should be under 1 under normal circumstances, unless you're doing something pretty intensive. So any case, this is, so right now this is showing it in a tree, my processes in a tree structure. And you can turn that on and off with F5. So F5 like this, you can switch between tree structure or not. Now I'm going to zoom out a little bit, so you're not going to be able to see the exact text that I'm running as that I'm. You're not going to be able to read the exact text as easily, but you're going to be able to see the overview of what's going on. So hopefully that works out better for everybody watching this video. But I'm going to zoom out and just resize this window real quick. So Control minus. You know, I'm going to close this other terminal. Now let's see, Control minus. Now this should give you a better view of everything that's running here. And let's see if we can line this up just right. All right, close enough. All right, so now F5, you can press F5 to show a tree structure, which is pretty neat. And you can toggle between the tree structure and not having a tree structure. Now you can press capital H to turn to show if you don't want to see all of the threads. You can say Shift H for a capital H, and that's going to only show you processes. And you can press it again to show all the threads. And so if you only want to see processes, or if you want to see all the processes, including every thread of each process, that's how you toggle between them. There are a lot of options. I'm just going to show you the most notable ones. So you can press. I'm going to show you another quick example, real quick. So in tree view, you can do, and then I'm going to show you I'm going to show you the help in just a minute, but I'm going to show you this real quick example. So you can type F4 to filter out for a certain process, and then you can type in whatever you want to filter for. So I'm going to say Chrome, CHROME. So I'm going to only show you Chrome processes, and this shows you the structure of all the Chrome processes. Now, let's see. You could, if you press Shift H, it's going to. I'm not sure why it's doing that. All right, I'm going to kill this. Oh, because this is okay. Because all right, I can press Shift H without filtering, and that's only going to. And then I'm going to press F4, and I'm going to search for Chrome. Now this is going to. All right, so I actually just turned on. So these are all of the Chrome. This is just Chrome stuff, and this is like page after page of Chrome thread. So you can see there are a lot of threads in there. And let's see. You can turn threads off, and you see there's only this number of processes. So you can see this is the number of Chrome processes running. Turn threading on, and this is the number of threads. We can just keep paging down and down. There's a lot. So any case. So moving along, you can press, if for help, you can press a lowercase h or F1. So lowercase h is going to show you all the options. See, like you can switch between tree view, toggle program path, all sorts of stuff like that. So set CPU affinity, all kinds of other things. Now we're going to get out of here, and I'm just going to show you a few notable things. So if you want to look up all the options you have, you can do it like that. So you can do a capital N to sort by PID. You can also use a capital P to sort by CPU usage. And you can see my top thing is Voco screen, which makes sense because I'm recording my screen now using Voco screen. So yeah, that makes sense that would be using the most CPU. So you can do a capital M for memory usage, and it's again Voco screen by far using the most memory, followed by GNOME shell. Now you can do capital T to sort by command, and you can see Chrome has over time it's used up way more. It's used up way more time on my system. Now followed by Voco screen, followed by GNOME shell, and then Voco screen. So what else do I want to show you? So for a given process, I could show you the environment for this process. So you can use the arrow keys to scroll through and select different processes and do things to these processes. Like you could kill the process, like an F9 will kill a process. You can use like an F7 or an F8 to increase or decrease its priority. But in this case, I'm going to show you can use an E to show the processes environment. So type a lowercase e, and it's going to show you the environment for this process. So this is the environment that I launched the process with. So if you, it's usually going to be your, depending on which user launched the process, and whatever else. So if it's something you launch as yourself, it's going to usually be your default environment. If it's something you launch in maybe like a daemon you launch from a script or something, it might have some environment variables set in that script, and those you'd be able to check what environment variables were set for that process right here. So this is kind of really useful just to be able to see the environment of a process to help you debug issues and figure out what's going on, stuff like that. So pretty useful. Hit escape to get out of there. Now you can also do an L to basically run LSOF and show what open file handles a process has. So I can run L, and I see this is not just going to show files, but it's going to show all file handles. So this means any sockets for inter-process communication, and sockets for like network communication, sockets for basically everything. So and some of these are going to be actual files. So like the ones that say Unix, these are going to be like, I believe these are for inter-process communication, whereas like this one right here, I believe this is a regular file. So this is, you can see this is accessing the trash and a log that's in the trash. So a bunch of different files are being accessed by VocoScreen. Let's see, I guess these are regular files, but all right, so these are font files, I guess. In any case, it accesses a lot of stuff. So hit escape to get out of there. So let's see, what else do we want to show you? I believe that's everything I wanted to show you. So that's a quick overview of what you can do with htop. So yeah, my top 4 favorite Linux commands are going to be tree, htop, netcat, and lsblk. So I think those are pretty handy tools that are also interesting, that not everyone has necessarily come across it, especially if you're a beginner. So hopefully these are useful for some people. If you found these useful, give me a thumbs up. And if you disagree with these, if you have your own favorite Linux commands and maybe they're different from the ones that I picked out, leave a comment down below letting everyone know what your favorite Linux command is, or if you think my list should have been different, what Linux commands deserve to be mentioned a little bit more. Just leave a comment down below. Not just for me, but for anyone else who comes along and watches this video. Also, you want to hit that subscribe button because we cover a lot of great stuff on this channel. We cover a lot of Linux stuff, server-related stuff, networking, hardware, software, coding, scripting, automation, robots, Raspberry Pis, electronics, 3D printing, lots of great tech stuff that you're going to want in your YouTube feed. So definitely hit the subscribe button, but also hit the little bell icon. Otherwise, YouTube won't let you know when we come out with new videos. And that is about it for today. So thanks for watching, and we'll see you guys on that next video.